and we can kick this off. Well, thanks so much for joining today's webinar on getting unstuck, how not to get locked into one LLM and benefit from all best-in-class LLMs. We are super excited. We have a lot of content to cover today. And without further ado, let's hop into the next slide, please. Today's speakers, with me is Fabi, the CEO and founder of Pulse AI, who will be sharing his wisdom on the LLM space, and we'll be talking about using and leveraging different models. Fabi, if you could give a brief introduction of yourself.
Yes, thanks, Christian. Very excited to be here and talking about model lock-in. My background before I started Pulse AI is I was working in biotech and in distributed systems. Originally from Germany, I built their data centers, and then here now with Pulse AI, really working on the machine learning side of things. So very excited, and also bringing in the distributed system knowledge into the space.
Excellent. Thanks, Fabi. And my name is Christian. I'll be the host of today's webinar. I will be behind the chat. We also have Marvin from our team, who's also behind the Q&A box, which is a shameless plug. Please make good use of the Q&A box. Feel free to ask questions. I might interrupt Fabi here and there throughout his presentation in case there's any relevant questions that we could ask right away. If not, there will be time at the end for Q&A. So we will surely get to your question if you write it into the Q&A box. And with that, Fabi, let's jump to the next slide.
Awesome.
Today's agenda will be market overview. We'll talk a little bit about the different LLMs that are out there, what we call the LLM trap, talking about the model lock-in, routing and benchmarking. This is really the key essence of today's webinar, how the routing and benchmarking works. We'll go through a demo of Pulse, basically how a very hands-on experience on how you can leverage Pulse to avoid the LLM trap specifically. And then we talk about LLM observability because it's very timely. In fact, we'll be heading to London next week to go and join Grafana at their conference to talk about LLM observability. So we thought, given that this is also a very new feature that Pulse has released, that we would cover it today. And then, as promised, the Q&A in the end. One important thing I do want to point out is that we are grateful and thankful for you taking time out of your day. We will make best use of your time. We maybe present for about 30 minutes or so, and then leave 15 minutes in the end for Q&A. And we try not to run over to make sure you get to your next appointment. And with that, Fabi, over to you. Let's kick it off. Thanks.
Thank you, Christian. So let's start with looking at today's landscape of large language models and why there could be something like a vendor lock-in. Since 2018, I think the space is exploding. There's this evolutionary tree almost happening where you see that different sort of flavors of large language models emerged. And we see that specifically the decoder only ones of the GPT-1 first and GPT-2 are now getting into the more interesting space that has most applications at the moment, most famously with GPT-4. But it seems like almost every other week there is another model coming out. This week, GPT-4 Turbo, then a lot of open source activity as well, with Meta's Llama's models. But we also have other smaller players that come up with these foundational models. So really, the premise here and the hypothesis that we at Pulse also have and see validation already is that there is a world where there will be millions of these models. Almost like that there's not one giant model to rule them all, but there will be smaller expert models or specific models that are very good in specific tasks. And so it's really up to you to figure out which is the best model for you. Do I have the model fit, or do I not have that model fit? And that gives us a challenge. We don't know if that specific model works for you. How would you know? Also, you sort of get a little bit of the fear of missing out here, FOMO, because if there's a new model coming out the next week, is my current model right for me? Do my users actually benefit from the new model? How easy is it to switch? These are all the questions that come up in sort of a world where we see millions of these models. So it's not very easy to navigate through such a world. So there's really this trap. Like think about model lock-in as I started building my application for this one specific model, and then I see that that model is maybe stuck in time. It's frozen. The famous September sort of 2021 training. That is maybe fine if you do this like very close to that sort of like time frame. But like as time goes on, sort of there's a big gap that starts, and can you easily switch to another model? Is that model like basically like good for you or not? That's those are the problems that you have here. And then it's also like if you just go with one specific model, you may be missing out on a lot of other opportunities when it comes to, for instance, also how fast the model's responses are, and these sort of things. So there's really this model lock-in problem that we see in the space emerging. And what that brings with you as well is that the costs are very uncertain and they can threat margins. You can think about building your entire application for one model and you sort of stuck with that model and that price structure. Meanwhile, another player emerges, comes up with a way better quality-wise, but also cost structure-wise model. And switching to that model is really hard. And it shouldn't. It should be very easy. You don't want to rewrite your entire application. You don't want to worry so much about like the sort of like implementation of this. This should all be like a no-brainer. So the cost of switching is also something that you need to consider. Not just the cost, how expensive these models are. It's almost like if you think back in the days with like Dropbox and Google Drive with hard drives, how expensive hard disk and disk space is, and that it was very expensive in the beginning, but the cost tremendously came down after certain generations. And we're seeing this already in the space currently emerging as well, that older models are very expensive, but newer models, they are like 2-3 times cheaper than the older model, and so forth. And then thirdly, also another point that is the quality of these models. They could be black boxes. Well, there are some of these that are, for instance, open source, where some of that stuff is very transparent. The weights maybe as well, but like mostly it's treated as a black box. Think about like Anthropics or Claude AIs or other foundational models that lock them behind APIs. You don't really know with what data these models are trained, sort of what biases they have. I really see open source here as sort of one of the answers to build like very reliable quality models with an output. Nonetheless, there's also like a good comparison with Linux as an open source operating system, which became the de facto like system on which the entire internet runs. It's open source, and that makes it super safe. And I think the same logic applies also for like large language models. The open source models will be the ones that are super safe and not in the hands of a few. But yet you need to find a way to basically like get value out of both, so they are not such a black box for you. And that's really, and I will talk later about this, our knowledge graph, our unique scoring and benchmarking that is built on open source data sets. So it's very transparent and helps you to basically like make this a white box, not a black box. And then lastly, there's ongoing maintenance and upkeep of these applications that you build. Think about like features that are suddenly available for you that your users want and that you can't have right now. Interesting features, for instance, are you build against OpenAI with cloud functions, with function calls, that you can basically guarantee sort of like the response in a specific format. This is great if you build the application towards OpenAI models, but what happens if you build them against like Anthropic, Aleph Alpha, AI21s, or Cohere models? There are no such like functionalities. And so that is requiring a lot of upkeep and maintenance, particularly also when you want to switch it. And so there needs to be some solution that allows you to make the switching very like easy and simple without basically justifying that rich feature set that got you chosen to that specific one model. So in hindsight, or like a conclusive, there will be almost every other week now a model that evolves, and it's really hard to integrate with that model almost automated and securely, such as that it doesn't break your production ready and application. And so how can we solve this? And we think we can solve this by making it look like you built this application against one sort of platform, but actually what happens under the hood is it's abstracted away from you, and you can reach with one request, not just like an OpenAI model or a meta model, but you can reach the catalog of all top leading models that are currently out there, curated by a player. And so our dynamic routing platform is exactly this. With our dynamic routing, we basically route those requests based on 3 dimensions, which are quality, cost, and speed or latency. And that gives you, the user, the opportunity to basically decide for which request you have what preference, and such the model has been chosen. So you can almost think about like a matchmaking here. And that happens between your request, the prompt, and the actual model. On the other side, that abstraction layer allows you, similar how we saw in the last wave of compute, where everyone was moving to the cloud, really to build like resilient and scalable applications. With the move to the cloud, I think it was evident that microservices were like super helpful when it comes to building scalable applications, with the emergence of Kubernetes as sort of like the platform on top of which you can build applications. You're no longer locked into one specific cloud vendor, but there's now an offering of Kubernetes as a service for Google, on AWS, on Azure. It's really like you don't need to know the ins and outs of each platform. What you can do as a platform developer, application developer, you can just go and develop an application on top of Kubernetes, and the rest has been taken care for you. And the same thing as what we're trying to achieve here with Pulse AI. You need to just build an application for large language models on top of our platform. And if you build it on top of OpenAI or on top of Anthropic, it actually doesn't matter. It's all tightly integrated with each other. And so you don't have to worry for it. You can actually focus on your core product, which is building and adding value to your users without these smaller technical implementation details that can be also quite cumbersome. At the moment, we support over 32 models. Almost every week, there's a new model that gets added. So that catalog of curated models is really important to us, such as that we give the user the choice, that we democratize for the user basically the large language model space. So you're not trapped with one provider, but you're also able to switch after maybe 3 months or 6 months. So we can grow actually with you and your users and your application. So I want to change gears here a little bit and show you a live demo on how this would look like on top of our platform. So on our platform, you can create very easily an application. Yeah, go ahead.
Bobby, sorry to interrupt there. We had a question in the Q&A box, and I think it's very relevant time-wise. What models, the 30 plus models that you mentioned, what models do you have supported? And I think as you're helping to the demo, this will be great to jump into, just to highlight. Thanks for the questions. Perfect. By the way, everyone that joined a little later, please make use of the Q&A box. Feel free to drop your questions in there. I like to interrupt Fabi every now and then, but we will also have time at the end for a Q&A session. All right, sorry, Fabi, over to you again. Cheers.
Also, no problem. So to answer directly that question, when you create an app on top of our platform, under the models tab, you see which are all of these models that are currently available, from which provider they come. We have the description, we have the context window as well. And specifically for your application, if you want to basically like just pick on your application one specific model, you could just go and deselect all of the models and just cherry pick basically your provider or your model, which is super interesting, by the way, as well. If you don't want to send your data all to one specific provider, but you maybe want to like send it to another provider that is in favor for like specific like tasks and specific qualities where you know already that worked. Most of the time we saw this like folks were building with one specific provider the application, and they basically like switched to us by just selecting that specific provider as well. So there are no other like providers considered in the routing request. So it feels like basically the same. It's very easy, that switching cost. We have 32 models total added to our platform. with every week we add more models. There's a very good balance between open source and closed source models. But the most interesting part really is also that we help you with like choosing which model is best for your application by, and I will talk later about this, by basically like identifying which of these models are basically very good at, and then when a request comes in, picking the right one for you where we think this is the best approach for you. But you can of course add some policies on top of this and show. So going back to our application ones, you can just create a new app. You can just call it Model One. Create this application. It creates to you that secret key. And with that secret key, you can go and basically like just switch already your API key and base URL, if you use, for instance, OpenAI, to us. And then it's backwards compatible. So your application is not basically changing. You have basically the same experience, but now this has been routed to us. And a lot of the times, the added benefit here is that we give you also observability with these sort of like requests. So you suddenly get logging for costs. You can create alerts and these sort of things. But you're basically like baseline of the model doesn't change. You're still sticking with the model that you have. That is something that we can do through Python with the OpenAI SDK. You can do that directly with Python within the request library. You can do it within Node as well. You have the option also here as an example of custom labels that you can show, weights. You can integrate via LangChain or Llama Index very easily with us as well. It's basically just coming down to changing 2 lines of code by pointing the base URL to us and swapping your token with the token that we just created. Then again, in the model view, where you have so many models to your fingertip, you can even say like, another way of thinking of this view is actually like, these are all of my models that you should consider when a request comes to this specific application. And if you just basically select one, well, there's just one to consider. But we encourage users to basically like very broaden up that space of models that can be considered, just so you get the best quality answers. Further, you have a settings view. Are there more questions, Christian? Yeah.
Yes, popping in here with some questions again. There are two which are fairly related, and I think you're going to that anyway now. One is, how does the evaluation of these models work? And there's later on in the webinar a section where we go pretty deep into this evaluation specifically, I know. And then there is another question. Can you explain how the routing works? I know there are 3 parameters it uses. Is this all the router uses, or is there some classification from text and or embeddings semantic score?
Yeah, that's actually
so
after this demo. Yeah. After this demo, I can talk more about this. So let's like put them in the backlog and then remind me on it if I haven't yet. So partly how this routing also works, to go a little bit in that direction, you can have your own preference. So you can say for every request, basically like, what are my settings? What are my weights? For instance, here we have reasoning and speed, these 3 dimensions, which like help us coming up with a score, figure out which request should be routed to what model. You can have a very strong focus here, for instance, on quality reasoning, which would be the preset here called quality. Or you would have a focus on, you just want a really faster response, that would be the speed reset, or the cost where it should just be cheap no matter what the quality is or what the costs are. You can find an interesting balance in by toggling these sort of like weights a little bit specific to your app. We also have the playground in which you can basically go and experiment with it, explore, and find the right balance for you. Further, you can add policies. Like you want to, for instance, if we have like 5 models selected for you, that would be the top, the best model for that response, but the top one was failing for whatever reason. Sometimes also providers could be down or have a very long timeout. Then you can say like, oh, I want to have an exponential backoff of maximum this, or also hop to the next 3 models maximum. So that's sort of what the policies that you can attach to every application are helpful for. And then you can also give a maximum token budget. How much do you want to actually burn as a total for each of the requests to control your costs a little bit? That's something that you can add as a policy too. Then when you integrate tools like Llama Index, for instance, and build your own RAG pipelines, there are optimizations that can happen as well. So we don't have to send all of the requests to that specific model. We want to avoid that model login. So there are maybe, as like you extract specific keywords from bigger prompts or from bigger corpus of text, a copy of text, you can go and optimize there as well. And we saw, for instance, then Atropic instruct v1 is really good when it comes to like following these instructions and on it for a very cheap price, extracting the keywords for you. So you don't have to do that, for instance, with GPT-4 or other models that would charge you way more for the sort of like same quality. And then also logging is another important feature where you can go and say, hey, I don't want to have like all of these things logged. I just want to have, for instance, the responses logged and so forth. So you have different levels of logging here that are stored in our, to be compliant, of course, with whatever regions in the world you are. Christian, there's another question.
There's a question, especially as it comes to weights, and I think it could be pretty relevant right now. How do you quantify the weights?
Yes. So how do you like the interesting part with weights is you can compare apples and bananas. So we basically normalize these weights. And so currently they can all be just like 1. And so it's from 0 till 1. I give you actually later an example. Let me jump to that example in a second, where you can see how you can like maybe say like 0.2. Like I have a little preference maybe for latency, so I give 0.1 to latency, but I have a strong preference for quality, so I give like 0.9 to reasoning or quality in that scenario. And that way we how hard is it to compare a model with the latency versus with the quality? So we go and basically like normalize it. So it's ultimately apples compared with apples and not bananas with apples, if that answers the question, hopefully. But it will be clearer when I come in a minute to the demo or so. You also have the option to upload your custom data, and we will work on more integrations on that. At the moment, you can upload your text file, PDF files, and so forth to have sort of like a rec pipeline built in-house already for you with just like uploading your files, so you don't have to do much work there. We're also planning to integrate with external providers that are really good with building these rec pipelines to give you there, again, a choice. And there comes our scoring into play as well, because what we really want to do is we want to be agnostic. We don't want to go and have like an opinionated approach on how to do that. Through our scoring, we want to figure out which of the approaches are the best ones that work with your specific data, with your specific app, with your specific use case. Then also we have logs available, of course, which is like very powerful when you build an application. Currently there are no logs, but let's just create a log here in our playground, again, where you can experiment a little bit with these requests. We have some prompts already configured for you under the category generate, for instance, if you want to generate a blog post title. Let's just click that. What we see here is like we define for you a top choice, currently Anthropic Claude Instant v1, with sort of these sort of preferences and weights configuration. But we also, just for the fun and the heck of it, went out and made 3 requests. Total 1 to the model that we chose, and then 2 to 2 other models that were competing with this prompt, but we never actually made the request to. So we can see actually what that request would have looked like if we would have done it, and we can super easy compare this. And so here's the score calculated, the normalized score. Basically, it's not like 50 score values or so. It's 1 score to keep it very simple. And you have your 3 prompts and responses next to each other, so you can compare, and you see why we chose in this scenario for you Claude Instant v1, because it got first the higher score when it went to quality. That was one criteria for this specific request. But then also at the same time, also compared to, for instance, GPT-4, why you had like cost savings there compared to other models, depending on what your preference was. So if we do the same thing now, then this gives you here just the idea basically to just play around with your tokens that you have, with the creativity. You can go and also like change this here a little bit and move everything down to 0, and then start the same request as well. Another cool feature is that our playground is keeps the content and is basically like you can have a conversation going, so it remembers the previous interactions. You can easily just like clear the results and start basically from fresh. Before I jump into the coding part, the other part that I really wanted to show you is that you have org management as well, which is super powerful, where you can go and add members to your organization. You basically also add billing. You can add basically like your credit card. You can see you can add multiple like providers there that you want to pay, and you get an invoice and get it very nice like displayed across multiple providers, so you don't have to run to multiple providers and see which one you have to bill if you have a quota and so forth. You can also like set settings for your application. Comes about any as a no-brainer, but like then you have also like integrations, and we're very proud to partner here with Grafana to just super easily ship all of your logs to your Grafana and cloud integration and have there a dashboard. We're currently the only one who has a large language model dashboard for your operational side of things, where you can identify basically like how many costs you burn, how many tokens you burn with what model and so forth, and can build your own alerts. Yeah, Christian, there was a question, I guess.
Cool. Yeah, there are two questions which I think would be worth covering now. There was one question whether one would pay all these models for each API call. How does that work? So do we send one request to all models all the time, or are these broken down?
Yeah, in the playground, that's a very good question. In the playground, we send this one request to 3 models, and just so you get this comparison, and we show you which is the one that we, when you would have done it through the API, would have been as the sole model to which we sent that request being selected. If you choose us as a developer through the API, of course, we just send that to one model. And the power here really is that we went ahead and pre-computed that knowledge graph already beforehand, so we don't have to pre-compute it every time there comes a request. So we know which of these models work best with what prompt, and that's really how we can also get like a very low latency. Between 15 and 25 milliseconds overhead is typically the latency that we introduce when it's just about figuring out which model to choose for you. And there's
awesome.
actually
and then,
like, yep.
Yeah, and just a quick time check. We are at about 30-minute mark. And with that, I will stop asking you a question and interrupting you, and we'll keep all the other questions to the Q&A.
No problem.
There's too many coming in.
Yeah. So I'll like with the observability part, with the cost and what model was chosen and so forth, I think what's very powerful is that we provide you also Prometheus metrics, and we're tightly integrating with the open source framework and net ecosystem here. So what I did, I just spin up a local Grafana Docker container, and I added as a data source, basically as a Prometheus data source, our Pulse API. And you can do that even now by just adding our base URL and just adding these metrics / prom suffixes, and using the secret token that you have for your application. And that way, you can very easily, as authorization header, basically make requests, known requests through Grafana to a Prometheus data source. So it will look like that this is your own Prometheus server that actually runs. And you can start exploring the metrics. And so if you want to do this here in this scenario, let's look at the Metrics Explorer. We have a bunch of these metrics available. The ones that I want to point out today are, for instance, for your specific application, the total costs. So let's just select these. And there are currently no costs because we didn't do a request. But let's just go ahead in this application that we just created and make another request. Let's just go here and make a request in the playground. We would see in the logs that this specific request would be now like 3 requests, and the cost would be reflected as well then in our Grafana dashboard if we want. And I can actually show this also how this would look like from the code's perspective. So also to your question with the weights. So I came up with a very basic app. I have my own labels for which I also can filter later, set policies. And I can send with every request my weights, which override basically whatever that default for that app is. And so let's pick a math problem here. Also, by the way, if you decide to make a chat request, but some models are not chat endpoints, we convert that for you as well, which allows you also to like tap into even more models that are available for that specific request. Here, let's just like target a specific model. This is the normal chat completion request that I would do with OpenAI. I choose GPT-4 here. I would make that request real quick. That would look like this. The answer would be 2. That's what OpenAI gives us with a total cost of $0.009. But we also give you a more like raw response that you can use for either like your own sort of heuristics when it comes to logging, but that's the one that you also can have within our application in the logs field and filter for and see what the responses were. So you can go afterwards in our platform and actually have all of this available to you, filter for it, search for certain things, figure out also your customer success team, what was wrong with my specific prompt or why was this failing for that specific customer, by just like sending a label with a user ID for that customer, for instance, and just filter for it. One thing to mention is that we introduce a new field, which is the metadata field. And in that one, you would have your app ID, the category on which this request was categorized, the cost savings compared to GPT-4 in this case, because it was a GPT-4 request, there are no cost savings. Also the overall costs, the labels that I just added here, also the weights that were used for that specific request, the latency that this specific request had, the maximum of tokens, and also a little recommendation on like for this specific request, which one would we have chosen for you? And turns out we would have chosen GPT-4 for you in that scenario. Exactly, cool. So now let's change a little bit the code here and say like, I wanna have maybe not directly targeted GPT-4, I wanna maybe choose Pulse as a model request. And maybe there's a model out there that makes it cheaper than GPT-4 for us. Let's see. So if we do that request, we see, oh, no, GPT-4 still for this one with the highest quality is the best answer. Great. I mean, that's what we expected. Let's just switch these ones here to maybe, let's see what is currently the best quality that we have. And so what I would expect here is that we find now the model that is not solely like for the quality, but actually like the latency should be the one that is the interesting one that we can figure out for you. And there we chose at the moment Aleph Alpha Luminous Supreme Control, because the current like requests that we do on our platform basically showed that the last request was so fast. And that's why we chose this specific model. Also, the price that we have here is also one thing to in consideration. Let's say we want to say just one that is super cheap. We can go and say, okay, let's just have our focus here on the costs and then start making the same request and see what model in this scenario was chosen. Maybe not Aleph Alpha, but maybe another one. And here it's Mosaic ML. With the 7 billion instruct that was way cheaper and also gave us an interesting answer here with its 2. So depending on what your preferences are, different models are chosen. All right, cool. Let's jump back into the live demo. So the knowledge graph that we built is basically like a replay of like a lot of open source data sets, and it looks like this. It's basically like every sort of like category is a different color and it organizes itself in that semantic space. And so if there are a lot of math problems, for instance, these are organizing maybe in the color of red in the top left here or in the button. And we are dynamic as like new requests and prompts come in, we figure out that there's a new category evolving and we cluster it and then basically replay for that specific category prompts that are representative for it with our models to figure out the blueprint and fingerprint of these models, what they're really good at. And this happens through the knowledge graph that we built. At the moment, the knowledge graph that we built is a knowledge graph that uses our own fine-tuned embedding model based on SBERT that knows the intention of your prompt. It knows that if you ask a math question, that is a very good representation of a math problem in our vector space. And we're going into our vector database, which has these pre-computed example prompts that we chose from a lot of open source data sets that were, for instance, also with math, to then like identify which models were particularly good with this sort of like dynamic category. And then we are able to compare that with a semantic search by, oh, your prompt comes in, it's a math problem. Let's figure out in our vector database what are the nearest prompts that we played already and decided and scored very high for that specific category. And then we do that same request to that category. And what this allows us is through that distance to be number one dynamic, but also not having a lock-in. So we can choose multiple embedding models. Later to that banana and apple comparison, we can also compare like the task that you want or a specific outcome that you want that is specific to your application. So it doesn't have to be just intention-based. Intention-based is just one of the typical models that would do that. That is, for instance, also like how GPT-4 works. There are a bunch of expert models under the hood that help you with that routing decision. And then lastly, though, we also allow you to add your own sort of flavor of like influencing that scoring decision by your preferences that you have. And we're planning to even add more to these. We would even today make this dependent on your application. Let's say you have an application that is just in the restaurant field and people asking for reservations for a table. We take the data and basically build your own personalized knowledge graph, such as that for this specific application, we have a unique routing experience. All right. And that looks at the moment like this with the categories that you saw. We saw already that some of these models are performing very well in specific categories versus others very poorly. For instance, Goose AI seems to be very poor in most all of the categories, whereas we see that Aleph Alpha's Luminous Supreme is in most of the categories not as good, but in others, other models from Aleph Alpha seem to be better as well. And that helps us really to choose for your specific unique prompt, which model should we send it to. And so the benchmarking that we do for these replays is answer-based, which is we use a lot of open source golden files, Eleuther AI's harness, where we have a lot of prompts with already answers, then compare basically like if we send it to all of these 32 models on our platform, like how these answers compare to the golden answer. But then also use other tools like from Stanford's Helm benchmark to really democratize it here and run the global knowledge graph with as much as representative prompts to get a very 360 picture of the current landscape, how these large language models perform, and also how they drift and perform over time. And then for the ones where we don't have a right or wrong answer, we use our sort of like LLM terminant approach, where we do ELO ranking, like in sports, where we have like two very good prompts answers compared with each other and figure out which one of both of them is the better one that helps us for a lot of these open-ended questions or also new sort of categories that are forming to choose the right quality and give you the right response. And this actually breaks down into like the following cost savings. If you would choose, for instance, just GPT-4, this would like probably has the highest cost at the moment that we see, but also the highest quality. But we're able to identify that arbitrage, that there is another provider, another model that would, if it would have gotten the same request, gave you the same sort of answer or like same quality of answer, but to a way cheaper price. And that's what we enable us through our dynamic routing, where basically that same request could have gotten to to an open source LLM that is way cheaper, and you have some cost savings here, up to 70%. And how we can achieve that is also enabling the users on our platform to come up with their own large language models that are custom tailored to their use cases, their own fine-tuned Llama 2 models for specific use cases, trained with their data that gets then scored with our benchmarking capabilities. And you have your own personalized knowledge graph where we choose then this sort of application, this model for you over an expensive GPT-4. So it's very exciting if we use this model optimization, basically like to bring your costs down. And in many cases, we see that sometimes up to 90% even. Yeah. So observability is also something when you look into costs. I think a great shout out here from folks over at Grafana, where you can meet us next week in Observability Con, where we showcase that more, where we showcase a global dashboard on which you can access basically like all of your application and organization prompts and see which models are the best models and why they burn basically like these tokens, which models are chosen, what are the costs. You get like the total overview of how your application is doing, the state of your application, the health of your application, and that enables you even to build further down better applications and a better user experience. All right, so Christian, over to you. Also 2 more questions, I guess.
Thanks so much. Yeah, that's right. Thanks so much for walking us through this, Fabi. Highly appreciate it. And there were a lot of questions coming in. Thanks so much to all the attendees asking questions. We have still some time, so we'll go over a few of them. But before we do, shameless plug, if you want to meet Pulse in person, we will be in the Bay Area next week, as well as in London, as Fabi has already mentioned, at Scale by the Bay, where we'll have a booth, and you will see Pulse representatives on a panel as well. And then at Grafana, we'll also be in person. So if you're in either of these locations and you want to meet up, please write us a message. And with that, Fabi, if you go to the next slide, and you want to communicate with us more afterwards, feel free to join our developer community. It's a Slack group. You can just scan it right now and join it. And Fabi is part of this, as well as all of our engineering team members. So feel free to join that, and you can ask specific questions. And then there's also the link to sign up to Pulse directly if you'd like, if you haven't done that already. So there were a bunch of questions around pricing and how will I get charged, Fabi? So maybe let's jump into that. How will I get charged in terms of, let's talk a little bit about the platform fee and us staying neutral so that we can be the routing to the best model possible. And then that would answer, I guess, how I get charged. Oh, the other related question to that is how will I need to use my own APIs from the different model providers, or is there a Pulse one? That was another question. And then after we answered that, Fabi, we can jump to the time it takes that Pulse adds on top. There was a question around the slower response that I think would be good to get to as well.
Yeah, all right, cool. So at the moment with these requests, when you see we basically like as a consultant, as an agnostic platform, do these requests to whatever provider is the best provider for you. And we charge basically whatever that provider charges you with a little premium on top of that. Actually, we had that here in our presentation. We charge a platform fee, a very minor platform fee actually that allows you with a free contingent and volume that is usage based. And then it's really just like, depending on what provider was chosen, we charge a little premium. Then the higher you are in the tier of the platform fee, there's a bigger discount, but these are like at the moment very like small discounts. They're not as steep. At the moment, actually, we're like just having this pass through, but that's sort of the idea of our pricing model that we're currently implementing. You can do this already now if you see how much you get charged per request very easily by just like looking through your logs. You see actually every request and what the costs for these requests were. Here in this case, 001. And that is also basically one-to-one what would have been the charge if you would have used Mosaic ML. As we flush out that sort of pricing model, one thing to note is that you can also add, of course, your credit card information the moment we give everyone a lot of credit so they can experiment more with the platform. But you can also set specific hard limits and soft limits, such as that if this is an issue for you, for like, for instance, the spending that you want to have, you can basically like have a little bit of control there. You can also, through the observability side of things, go and basically set alerts and say, if I reach for a specific application, for a specific label, for a specific app, basically like a threshold that I get a Slack message, a PagerDuty, and so forth. Yeah. And then the other question I think was about latency, how long it takes. One interesting thing here that we had in the demo was the max tokens that I currently have to 500, which sort of like increases the compute that the large language model actually has to do. So if we send it down to like 20 maybe, and I do the same request, for instance, here with latency, you will see that the amount of the responses are way faster. Let's do this here again. So doing this, and the response was way faster in this scenario with just like 20 tokens as max tokens. The whole problem space of the semantic space of new models that are considered changed suddenly, because there's a difference if you just say maximum tokens should be 20 or maximum should be 500 or 10,000 or even more. So the same thing happens here as well. And we saw in the latency here that this is currently 0.89. Of course, this is just basically from historical data that we have. Like the last request basically would be now for this specific model here, 0.89 seconds. That means if a future request comes in, we would have that as a lookup, and we know, okay, this currently takes 0.89 seconds, but maybe there's another model that is way faster for that sort of parameter combination, and that would have been then chosen. And you can always override this by adding your own max tokens, but by also like targeting directly the model if you want, if a specific model always should be chosen. I hope that answered that question.
It does. Thanks so much, Fabian. There are a bunch of other related questions, but we are at time. Thanks so much for all the questions. We will get to them and then send you follow-up messages. So we won't forget about answering them if we didn't get to them during this webinar. I do encourage you one more time to jump over to our community where you will be able to chat with us right away. Thanks so much for joining us. We hope it was good use of your time. And there will be more webinars in future as well, where we dive into some of these specific elements and talk about the prompting and fine tuning. And I know that there were some questions around these. We'll get to them and follow up with you after the webinar as well. Again, thanks so much for your time. We hope it was good use of your time, and have a great day. Until next time, bye.